Hello and welcome. This is an introduction to the solar system. In this video, we'll have a look at the main parts of the solar system, see how those things interact, then we'll take a trip to visit the planets and moons, see what they actually look like, and find out about their unique and interesting qualities. So before we explore the solar system, let's get ourselves a basic understanding of it, starting with the things in it. The Sun is the largest object at the centre, and everything goes around it. The planets and moons generally all follow the same basic rules. There are exceptions, but if we look down on the solar system so that the Earth has its north pole pointing upwards, planets orbit and rotate in the same anti-clockwise direction, with all their orbits close to being aligned with the Sun's equator. Moons do the same, orbiting their planets and rotating in the same anti-clockwise direction, and virtually every major moon has a locked rotation, meaning one side always faces the planet. There are 8 planets, 4 smaller terrestrial ones which make up the inner solar system, and then 4 giant ones which are in the outer solar system. There are also dwarf planets. They can have moons and rings just like the main planets, but on a much smaller scale. Pluto was thought of as a planet, but since then we found more celestial objects just like Pluto, and in 2006 the International Astronomical Union defined what a planet is. So officially, a planet can only be a planet if it is in orbit around the Sun, it has sufficient mass to assume hydrostatic equilibrium, meaning it's big and heavy enough to become round, and it has cleared the neighbourhood around its orbit. Only the main 8 planets have cleared their orbits, so anything else which orbits the Sun and is big and heavy enough to become round is a dwarf planet. The other 4 official dwarf planets recognised by the International Astronomical Union are Ceres, which lives in the asteroid belt, Haumea, Makemake, and Eris. Yet to be certified are Orcus, Quaoar, Gong, and Sedna, and there could be hundreds more out there. As we look down on the solar system, 2 things are very apparent. Firstly, things take a long time to happen. This is moving in real time, so if we speed it up, and then some more, and some more, and some more, we can see the closer a planet is to the Sun, the faster it moves, and moons do the same around their planets. The other thing about space is, it's big, very big, so ridiculously vast that it's hard for us to get our heads around because we have nothing to compare it to. So let's look at it like this. Imagine the Sun the same size as a yoga ball. The biggest standard yoga ball you can get at 75 centimetres across. Now picture it on an American football field, right on the edge of the end zone. If this is our scale, then Mercury will be 31 metres away, right here, and it will be 2.6 millimetres across. That's just 1/10 of an inch. That's how big it is, and how far away it is. The Earth will be 80 metres away, and it will be 6.8 millimetres across, just 1/4 of an inch. The largest planet Jupiter will be 7.5 centimetres across, 3 inches, or the size of a baseball. Still tiny by comparison, and almost 4 football fields away. And the furthest planet, Neptune, will be 1 inch across, and more than 22 football fields away, almost 2.5 kilometres. So far that light takes over 4 hours to get there. In space, things are big and stuff takes ages.